Hello, we're beginning a new series. Basically, this video is a continuation from where we ended last time, where I was looking at an example of switching on an LED. And so what we had last time, we had a circuit in which we said that there was a button connected to a port, particularly this is port A0, and then we have port B0, and in here we have an LED connected, and it's a light emitting dot, and then we have a button connected. Now we want to write a program. When I switch on this button, an LED connected to port B0 goes on. So in this lesson, I'm going to give you the version 2 on how you can do that. And to do this, specifically, we're going to look at instructions such as the SBI instruction. These are port processing instructions. We have the CBI instruction, we have the SBIS instruction, and we also have the SBIC instruction, right? So in here we're going to try to see if we can use these instructions to try to do the same thing that we did last time. But let's just go over what does the instruction mean. So if the SBI instruction simply stands for set the bit of a particular port, that's what it means. So now in this, what it means, for example, if I write SBI port A,0, this simply means set the bit of port A0, make it high. Alright, so if I have 0B, this will mean that you have a situation where we have, let's say if we had all the bits in the port were 0, then by virtue of that instruction, of this instruction, this will mean that if this is 1, 2, 3, 4, 5, 6, 7, 8, then it means that this is port A0. So this instruction says that where there is port A0, you now need to write a 1 there, right? So we need to get a 1, we need to write a 1 there, right? So it means that now, by virtue of this instruction, we change the port A0 bit. We're changing it now from it being 0, now we're changing it to 1, right? So if we say SBI port A,2, then it means that if this is port A0, this is port A1, then we're changing that port A0, 1, 2, then this one becomes a 1, right? So that's what the port A0, that's what SBI stands for. Now, if we try to look at the other type, such as the the CBI instruction. So the CBI instruction simply stands for clear the bit of a particular port. So if I write CBI clear the bit, so port A,2, so it simply means that if I had 0B 1 1 1 1 1 1 1, this is, so to clear the bit, so I'm looking at the particular port, So port A2, this is port A0, port A1, this is port A2, so it means I need to write a 0 on that particular port. Right, simple as all that. So that's how the CBI instruction stands for. So we know that this is port A7, and going down, this is port A0. Okay, so this is port A0, port A1, and then port A2. So this means you have to clear that bit, right? Make it 0. All right, very good. So let's go to the SBI. Maybe before we go to that, I want to show you something concerning the CBI and the SBI, the last thing to show you. So sometimes this SBIC is SBI and CBI instruction. These instructions may also work with the data direction registers. So for example, if I write SBI A,0. So what this means, it actually means that configure port A0 as an output port, because it's like you're setting the data direction register of a particular port. Since you're setting the data direction register of a particular port, so this instruction simply means that you will have to configure port A0 as an output port. So if you write CBI A,2, this simply means that you are clearing the bit of port A2, and this will actually mean that you're configuring port A2 as an input port, right? So there's the SBI to deal with just the port status, and there's also SBI to do with the direction. The CBI to do with just the port, but there's also CBI to do with the data direction. All right, so that's it. Let's come now to the other term. So we say again here, we're saying SBIS. So now what does SBIS mean? SBIS means skip the next instruction if the bit is set. Right, now what this simply means here is that you're skipping the next instruction if the bit is set. Now I want you to notice that the SBIS instruction does not go with the port, it goes with the pin. So now let me just give an example and I'll explain. So we have the SBIS, for example, we say pin A,0. So this instruction, let's say that this is instruction number 1, and this is the instruction number 2, and there's also another instruction number 3. So let's say that we have instruction number 2 to be RJMP switch on LED, okay, then this means RJMP switch off LED. So what this instruction will do, it tests if port A0, notice that I'm not writing SBIS port A,0, but I'm writing SBIS pin A. So it talks to the pin, and what it means is that I should skip the next instruction. I should skip instruction number 2, provided the port A0 is high, right? Because skip the next instruction if the bit is set. Now the actual bit we're talking about is the bit of a particular port. So this is port A0. So if I write pin A,2, it means I'm skipping the next instruction provided that port A2 is set, all right, or pin A2, because the port and the pin have the same information. So when I talk about the pin, I know I'm talking about the port. So if I say SBIS pin A,2, what this simply means is that I need to skip instruction number 2 if port A2 is high, or if there's a high status, or if there's a 1. Now, so the SBIS instruction is a testing instruction that looks at a particular port if it is set. If it is set, then the next instruction should be skipped, should not be performed. Otherwise, if it is low, instruction number 2 in this case will perform. So the SBIS looks for a 1 in a particular port to skip instruction, to skip the next instruction. In this case, to skip instruction number 2. So for instruction number 3 to perform, it needs that on port A2 there's a 1. If there's no 1, instruction number 2 will otherwise perform. So the SBIS instruction looks for a 1 to skip the next instruction. So the analogous command of this is the SBIC. Right? Just remove this. So the SBIC is the analogous command, and what this command says, it says skip. So the SBIC, now we can look at the SBIC. So the SBIC, what does it do? SBIC. So the SBIC says skip the next instruction if the bit is cleared. So you skip the next instruction if the bit is what? Is cleared. So let's just look at this. Okay. So if the bit is cleared, the SBIC instruction is cleared. So it looks for a 0 in a particular port to skip instruction number 2. So instruction number 2 will not perform if the bit is what? Cleared. So it says skips the next instruction, skips the next instruction if the bit is cleared. If it is not cleared, it will perform. So instruction number 2 will only perform provided if on A0 or 2 in this case is what? The bit in them is 0. If there's a 0 on port A2, then therefore we skip the next instruction. Alright, so that's how these two instructions work. And so there's some sort of a testing instruction, right, that help us to align, help us to test if the bit is set or if the bit is cleared. Alright, so now real quickly, let's just go through the some example on. We come back to our circuit diagram, and then let's try to write a code to mimic the same example that we had. So this is exactly what we had, and this is port B0, and we want to switch on an LED using these same instructions. So now real quickly, I'm going to match out of this, and then I'm going to try to address this using the same instruction, the SBI, the SBIS, the CBI, the SBIC, as yeah. So we try to use these instructions to try to approach this same question. So quickly, I'm just going to go to Atma Studio and try to write a code that will respond to this very same. Right. So let's try to see if we can write a code that will help us to approach the same question. Alright, but I'll also want to, as the program is trying to open, as Admin Studio is trying to open, we shall also try to go to Process and also try to set up the okay, so we have try to open up my studio. Produce at the same time. So I'm going to start a new project in Process while my admin is also opening. Okay, so now basically what we're going to do, and we're going to try to, of course from Process I just went directly while waiting for, but you can go, some of you who don't know how to use Process, and I think you can take advantage of this video to try to help you. So you can go into the PIC library and then you can search for @mega 32. Alright, and you can see there after searching, we can also just okay that. Right, and I'm showing you how it works as well here. You have an opportunity to learn. So we can also try to pick a device, and then so we want a button. Just pick the first button, just okay. Place it on the desktop. Alright. And you can also try to pick part again, pick an LED. Now I want you guys to know that once you type LED there, you should go to optoelectronics, because that's where the animated LEDs are found. So in this case, let's say that we're just going to go with the animated yellow LED. Okay. And then we put it there. Now we're dealing with port A0. Okay, port A0 and port B0. That's what we're doing with. Unfortunately, so what we were mentioning, we were actually saying that, let's see that we connected. Okay, so I'm going to zoom in a little bit to just bring it to your view. So we have an LED according to the example. We have an LED connected to port B0, right? Is that what we have? Alright, so there we have it. And so we can place the terminal and the ground on this port B0. And we can also take it a bit high, and then we can set up that, and then we can also right click to place terminal, and we can pick the ground. All right, so now this becomes your circuit setup. Are you okay with that? So we have the port connected to port A0. How do I know this is port A0? You can see that. And this is port B0, we can also see that, right? And that's where we've connected our LED. So now we go to Atmos Studio, and we'll try to write a program, and then finally to be loaded into Process, right? So basically what we're going to do in here, we're going to start a new project. And we choose assembler, and in there we can give the name of our project like switch on LED. Alright, that's the assembly component. Just click OK. The next stage requires that you pick a device. In this case, we are going to say we are picking Atmega 32. And in this case, we're picking that chip right there, and then we're saying OK. All right. Now from here, some crazy background noise I'm getting. Just a second. Right, now we're going to try to see if we can write a code that will respond to this. So basically we know what we do. First things first, we have to write the program function. So we say program function. So we say that in this case we're going to start with the dot include, and what we're saying is this is M32 def .inq. Okay. All right, so we know that we have to declare the program function because the program function contains all the libraries that are necessary for the chip to reference to. And then we know that the next step we can do is the declaration section. Declaration doesn't have to be there, but we just define. So I'm just going to define the def temp. I'm going to say that this is R16. Yeah, I'll just put that, though I'm not using that register. It's just for the sake of it, just to give you the logical flow on how your program should be. The third stage we can look at is the start of the program. So in the start of the program, this is where I'll just put one command RJMP init. And now I know, as explained before, that when you put RJMP init, you are jumping to a section which is called the initialization section. And the reason why you're doing so in its section is to jump the vectors and the interruptions that if you didn't declare that statement, the program will be wasting time to perform unnecessary instructions that are not meant to perform. These vectors and interruptions should only perform when you want them to, so you put RJMP init to make it go to the initialization section. So in the init, this is where now you need to begin to configure which ports are input ports and which ports are what? Output ports. Now in this case, I'm showing you that I'm going to talk now to a particular port using the CBI and SBI instructions. Now notice that port A0 here is to be meant to be an input port, and port B0 right here is to be meant to be an output port. I think that should be clear enough for us. So what we do now is to try to see if we can now configure port A0 as an input port. So in this case, I'm going to say CBI DDRA, 0. That simply means that if I write CBI DDRA, 0, it means that port A0 is, if I clear the data direction register of the port, it means that port is configured as an input port. So this means configure port A0 as input. That's the comment. right? So if I write again, if I'm going to write, let's just say that again, I'm going to also give the status of a port. So the status of a port, we're going to give it high because it's an input port. We want that when the button is pressed, so I'm going to use the SBI port A, 0. So I'm giving it a high status as a port. Configure, give high status to port A0, A, 0, port A0, right? Why am I giving high status? Well, for the reason that if I switch on the pull-up resistors, the registers inside, such that when the resistors, so that when we switch on the port, the status will change from high to low, right? So I'm giving the status and direction of port A. Now I'm going to come to port B0. Now port B0, I've already shown you here that port B0 is an output port. So therefore, we are going to configure this as an output port. So specifically, we can say that SBI DDRB, 0. So whenever I write A0 to the data direction, whenever I write a high, because this is set bit of the data direction ranges of port B0. So this is configure port B0 as an output port. Output port, and then I'm going to now talk to, so that is direction. I'm going to talk now to its status. What status should it be? Of course, it's understood that I have to go through CBI port. It has to have a status port B, 0. It has to be low because I don't want, so give status low, status low to port B0. All right, B0. Now, since I've done all ports, now notice how using this SBI, CBI instructions, notice how that I'm talking to a particular port, this specific port. About the other ports, I don't care. So for example, here I'm configuring port A0 as an input by talking to its data direction register, and here also I'm making sure that I'm giving the status high of a particular port, and this is very neat as well. Okay, and now we know that from here we need to move to the main program. Why am I moving into the main program? Well, the initialization section, I've talked to both the status and the direction of the two ports that are involved. All right, so now let's come to the main program. So in the main program, the first thing we need to do is to test if the button has been pressed. Okay, and for this particular lesson, I'm just going to show you how to use the SBIS. So you may just also want on your own to see if you can use the SBIC, right? So to test if the button has been pressed, we can use the SBI. Let's use the SBIC. So this says keep the next instruction if the bit is what is actually set. Right? So now which bit are we looking for? So we are trying to check this button if it has been pressed, and this button is connected to port A0. So we're going to talk to its pin. Remember, when we are using the SBIS, it goes with the pin, right? So we're going to try and look at the pin. So we're going to say that pin A, 0. So what this instruction says, it says that the next instruction that I'll write, it has to be skipped provided that there's a 1 on port A0. Now remember what we did. We said SBI port A, 0. Okay, that's what we wrote. So immediately we know that if the button is not pressed, this instruction is looking for a 1 on port A0. So if the button is not pressed, definitely there's going to be a 1 on port A0. But then now this instruction says skip the next instruction if the port is high, port A0 is high. So what instruction should be skipped? Well, if I have not done anything, remember what we've been referring to. If I'm going to close this button, there's this 0 that is here will override that 0. That is an indication that the button has been pressed. But if I've not pressed the button, this guy is going to be high. So I need to write instruction number 2. So instruction number 2 should be an instruction that is an instruction that makes me jump to switch on an LED. So I have to skip it if nothing has taken place. So for example, I'll write it down and then I'll explain again. So I'll write RJMP switch on LED, right? So here is the point. The SPSS instruction looks for a 1 on port A0. By default, this is what we've done. We've put the 1 there. Now, by the way, in the main program, guys, let me say there's always this start. We need the label, and then we need to end this with RJMP start. GMP start, because it's a loop that we put. Right, the main program starts with a label and then it ends with a label because it has to end in an infinity loop. Right, so now here's the point before I get there. So I'm skipping instruction. So this is instruction number 1. Now this is instruction number 2. Remember when I was referring to this instruction to switch on an LED will be skipped. The LED will not come on provided if there's a 1 there. If there's a 1 on port A0, we're not jumping to switch on. We'll skip this instruction. Otherwise, if there's a 0, then we can switch on the LED. So now the third instruction that should be, so if there's a 1 on port A0, the third instruction is what maintains the status. It maintains the off status because you haven't pressed the button. So the off status, so you want it to jump to, so let's just make it neat by saying RJMP maintain status, or RJMP switch off LED, switch off LED, right? Or let's say, to make it easy and I'll explain, let's say maintain status. Maintain status. I hope that's correct. Status. Now notice how I'm not putting any spacing because it has to jump. If you put some space here, it's going to be a bit messed up. So you can maintain that you're saying. So what does this mean? It means that the SPSS looks for a 1 on port A0. It says, okay, right. So we're saying don't skip this instruction if there is a 1 on port A0. So what instruction should be there? If there's a 1, I know that nothing was done, so I need to jump to maintain the status, to always maintain. If otherwise, if there's a 0 here, this was going to switch on because the SBIS instruction only looks for a 1. If it finds it, well, it skips instruction number 2. If it doesn't find it, if now there's a 0, there can only be 2 statuses. If now there's a 0, it means that it jumps to switch on an LED. Alright, so now we need to just now write what should be under these labels. So if I get this label, so what should be this? Well, this should be switch on LED, and switch on LED code simply means just to turn on. So if it finds that there's a 0, it won't skip this instruction to go to a label switch on LED. But the label switch on LED, we have to switch on, we have to set the port B0 high, right? So remember what we need to do? We can go back and make sure that whenever somebody jumps under that label SBI, so we can say SBI port B,0. So that instruction says set bit for port B0. Alright, and in here when I set the bit of port B0, I put the bit of port B0. I should always remember when I set the bit of port B0, I should always remember to, if I set the bit of port B0, I should actually always remember to make sure that I go back. So for example, if this now performs, we should go back, we should switch on the LED. If we switch on the LED, we should make sure that we go back RJMP start. Alright, so if it jumps here, it will just set the bit high, and once the bit is high, it will try to, the program will perform, so the program will jump to switch on LED, and then now once it performs under what this label is, it will switch on the LED, but it should always remember to go back to the label. It should always remember to go back to start to test this functionality again. So to test this functionality again, to see if any status may have changed. To see if the status has changed. So now we can also make sure that we put what should be under the maintain status label. So the maintain status label should be the label that maintains the port B0 in the off state. So we need to write CBI port B,0. But then now, so in our words, so I'll walk through the program again so we can, this makes it go back. There's already RJMP start. We don't have to put 2. Now here's the point. Let's just go back. No status. Status. Maintained. Now, if you see this question, now let's just go through it over again. So this instruction, what does it say? It says that skip the next instruction if the bit is set. If there's a 1, don't switch on the LED. It means no one pressed the button. So what you do is that you just jump to maintain status. The maintain status means CBI clear the port B,0. Clear the port B0. Okay, but when you clear, please go back and test. So because now you're going back to test if the port has been what? Has been cleared. So if there's still the bit is set, you would skip, you continue performing this label instruction. But if it is cleared, you're not skipping the next instruction, you're coming directly to this. And see, set the port B0 high. Why are you setting the port B0 high? The reason is simple here, guys, because now the status has changed on port A0. Because you're saying skip the next instruction if the port A0 is what? Is high. But then now here you find that it's low, so you're not skipping the next instruction, so you're making sure that since status had changed, so therefore somebody press the button. Okay, so now real quickly, let me just try to run this code. We're going to try to build the solution. Now, as you can see that there's no any errors, it means that the code was right, was written okay. And then what we can do, we can now go and look for the hex file. So we can say start. So hold on. So you can just go to open file. Oh, sorry about that. Actually, it's open file. And then you can go into the debug and then look for a file which has got the .hex extension. The hex extension file is the one that has got the machine code. Remember that we have to change the middle language, in this case being assembly. We change it to the hex file by executing the program. So you saw how I did it. I went to build the program, build the solution, and after the solution was built and there was no errors, so we had to go into open file. We went into debug and then we found this. So I'm gonna copy this, take it to a friendly place where I can easily come and locate it. So let's say I take it to my desktop and I take it to a folder called Mugala and I put it there, right? Let's just say paste it there. And then you can see here that this is the where I've put my hex file on my desktop. So to come to that file, I just need to go double click on my Proteus, go to program file, and go to desktop, and there was a folder called Mugala, and this is the one, and there is my hex file, so I can just load it and get it there. So you come to program, so your program file, then you locate where your folder is, where you placed it, where your file is, and that's it, guys. And if you run this program, let's try to run it. Okay, there it is. So if I close the button, the LED comes on. So here it is a point. So when I close this button, when I close the button, so what the program is trying to do in the main program is trying to jump to switch on the LED, right? By RJMP switch on LED. But then now if I lift off the finger, it means that there's going to be a 1 written back to this. So if it's high status, it's going to maintain. It's going to go to a maintain position. So once it proves that there's a 1 here, it will do RJMP maintain status. So if I again try to switch on, it goes to RJMP switch on LED. If I try to lift off the finger, it knows now that the status has changed. There's a 1. Whenever there's a 1, it will skip the next instruction and it will go and perform the maintain status instruction. So you can see here how the program works. Okay, thanks a lot, guys, for your viewing. And this is how we actually deal with the SBIS, SBIC instructions. And I would like you to try to also be comfortable to use this way of doing things, and I'll show you more examples as we go on. And thanks a lot for viewing, guys.